Number 11. The easiest way, I guess, to do number 11, if you look at letters B, C, and D, you've got a complete circle, whereas letter A is just the top part of the circle. And the reason you only have the top part of the circle is that this is the positive, the principal square root. If I had the negative of this, what I would have had is the bottom part of the circle, but I don't, so all I have is the top. But if you put this into your graphing calculator, y equals square root of 16 minus x squared, you get the top part of the circle. If you use the negative, which you don't have, you would have gotten the bottom part. And the reason behind this is when you take the square root, when you physically draw in a square root, you have to take both the positive and the negative. Here the square root was already there. They just did the top part of the circle. Once again, your graph would have figured that out for you. Number 12, it's a line. You could just graph this looking for the x and the y intercepts. Just graph it. The graph would show you where the line cuts across the x-axis and where the line cuts across the y-axis. But if you're looking for the y-intercept, I'm going to let x equal 0. If I do that, I end up with y equals 0 plus 5, for y just equals 5. There is your y-intercept. If I'm looking for the x-intercept, I'm going to let y equal 0. So this would be 0 equal to x plus 5. If I brought the 5 over, I'd have an x equal to a negative 5. So here's your x-intercept. Now, it just gives you the x value, but we know it's an ordered pair, so that's negative 5, 0. For y equal to 5, your x value is 0, so your y-intercept on the y-axis is 0, 5. All right, so negative 5, 0 for your x-intercept, and 0 positive 5 for your y-intercept. You want the y-intercept, let x be 0. You want your x-intercept, let y be 0. Or simply graph it and see where the line cuts across the x and the y-axis. Number 13. Your first perception of this is, hey, maybe I need to take this binomial and square it and get involved in all kind of crazy things. But the easiest way to attack this is to undo the square. To undo the square. And undoing a square means take the square root of it. But now when I take the square to the opposite side, since I am physically taking the square root, I have to consider the positive as well as the negative. Squaring undoes the square, just leaving me the thing, the radican underneath. All right? Taking the square root undoes the square. Now here I got plus or minus the square root of 5. Well, the principal square root of 5 is 5, and the non-principal one is a negative 5. So what ends up happening here, I end up getting two answers. If you look at this number 13, you saw that each of these had two different solutions. So solving this first one, adding 1 to both sides, I get 2x equal to 6, or x is equal to 3. And if I solve the other portion, if I add 1 to both sides, negative 5 plus 1 is a negative 4. Then x is equal to a negative 2. So you see that there are two solutions to this, and the correct one is negative 2, 3. And here again, he tries to play games with you. You know, he changes the sign. Look at the letter C. Same two numbers, but the signs are, but this is, just basic algebra. The key thing here is when you take the square root of 25, you have to consider the positive and the negative. If you physically have to draw in a radical sign, you are prompted to take both the positive and the negative square roots. If the radical sign is there for you already, well, you just take the principal one. Number 14, absolute value. Now, you know absolute value is going to have two answers. All right, absolute value actually relates to the distance from the origin. And if I say the absolute value of something is 7, well, the answer could be negative 7 or positive 7, both negative and positive 7, 7 units away from the 0 point. So this translates to at least two possible answers. Either this is equal to positive 8, or maybe the thing that's contained in the absolute value symbol was equal to a negative 8, but because it was enclosed in absolute values, I had to make it a positive. So two solutions, a positive and a negative. All these absolute value problems will end up with two answers. Solving this first part, I get negative 9x equal to 3, or x is equal to a negative 1/3. One solution. And as I look at my answers, I only see letter D that has one possible answer that has a negative 1/3. So if I've done this correctly, why am I going any further? I know it's letter D. That's the only one that's got a positive 1/3. You know, there's certain things you can do to help yourself out here. All right, solving the other, I end up with negative 9x equal to 13, dividing both sides by negative 9. I end up with my other solution, 13/9. But I kind of knew that already, because that, letter D was the only one that had a negative 1/3. All right, 15 is kind of similar to 13. In 13, we squared to get rid of we took the square root to get rid of the square. Here we have the square root. I'm going to square both sides. All right, I'm going to square both sides. Now, here's a common mistake people make. They don't want to treat this right-hand side that's a binomial as a binomial. They want to square the x separately and square the 5 separately. It's great, but it's wrong. Squaring gets rid of the square root. And if I FOIL this out, I'm left with x squared plus 10x plus 25. Bringing everything over to the same side of the equation, I get x squared. Let's see. If I brought the 22x over, I have a minus 12x. If I brought the negative 11 over as a positive, I'd have a positive 36 here. Now, this is interesting because if I factor this, I end up with x minus 6 times x minus 6. Here's a perfect case where you have a quadratic. You're thinking, oh yeah, I'm going to get two answers. Yeah, you get two answers, but in this case here, both these answers are the same. All right, if x minus 6 times x minus 6 equals 0, then either x minus 6 or x minus 6 are the same term. So I'm not going to solve it twice, because solving this gives me x equal to positive 6. Solving it again is still going to give, it's what's known as a double root solution. Yeah, you got two answers here, but they're both the same. All right, number 16. So, if squaring undoes a square root, cubing is going to undo a cube root. I'm going to cube this left side, and I'm going to cube the right side. All right, cubing undoes a cube root, leaving me just 2x plus 5. I can call this a radicand, but in actuality, a radicand is something under a radical. This is a cube root, so I'll call it a radicand. In any case, 2x plus 5. Negative 3 cubed is a minus 27. So you have a first degree equation here. I'm going to subtract 5 on both sides, and then divide both sides by 2. And I end up with x is equal to a negative 16, and that's letter C. What I'm going to do is, there seems to be a dramatic lag as I get to the bottom of, if I'm doing multiple pages. So what I'm going to do here is I'm going to just do these 1, 2, 3, 4, 5, 6 problems. That means you may have multiple videos, but I'm just trying to cut down the number of lag time. In the directions, I also mentioned that if you don't want to watch the video, you can go to that link that I have for the LiveScribe player. All right, download the actual LiveScribe PDF, pop it in that window, and it'll play right there. It's another way of watching these if the video isn't to your liking. It's going to be the same, but here again, I'm trying to cut down on the lag between me writing and you hearing my voice.